Okay, so it's 7:05 now, so I'd like to go ahead and get started with today's class. So for today's class, we're going to go through chapter 12, which deals with circles and angles, and then we're going to do some review problems from previous chapters, and then we will play a Kahoot at the end. And we will have a 5-minute break at around 7:45-ish. Okay, so I'll go ahead and share my screen.
I have double monitors, so I may look like I'm looking up.
Okay, that's fine. Okay, so chapter 12, we're going to be talking about circles and angles. And the first section deals with inscribed angles. So an inscribed angle, you can see an example in the figure on the right. So for example, angle PQR is inscribed in arc PR since its vertex is on the circle's circumference and its sides hit the circle at points P and R. And so basically what an inscribed angle is, it's an angle that is within a circle and its vertex and its sides hit the circumference's circle. And inscribed angles are very useful tools in geometry. So, as we previously went over, yes.
Well, it's kind of like, an arc.
Yeah, it's kind of like an arc, sort of. But it's basically, it's an angle that's inside of a circle, in simplest terms. So any angle that is inscribed in a semicircle is a right angle. And so if the angle only covers half of the circle, which is a semicircle, then it is going to be a right angle. So angle ACB is a right angle because it only covers half of the circle. Okay, so we have our first problem, problem 12.2. Points A, B, and C are on circle are on the circle with center O, so that arc AC equals 80 degrees and arc ACB equals 130 degrees. Find angle ABC. Sorry. So I'll give you guys some time to figure out this problem, and then we can go over it together.
Can you go back to the important points?
Yes. So that's what an inscribed angle is. And this is what an inscribed angle inside a semicircle is, so that's going to be 90 degrees. And this is the question. And remember that arcs and angles are proportionally related in circles.
No, Moshe. Come on, come on, come on.
Okay, so I'll go ahead and go over this problem. So the measure of an arc is equal to the angle formed by the radii that cut off the arc, and this is known as a central angle because the angle goes through the center of the circle. So what we want to do is draw radii to A, B, and C so we can form isosceles triangles as we have in the picture. since angle BOC is going to be equal to arc BC, that's going to also, that would be equal to arc AB minus arc AC. That would be 50 degrees. And then angle OBC is going to be equal to angle OCB, and that's going to be 180 minus 50 divided by 2, which would be equal to 65 degrees. Also, angle AOB would be equal to arc AB, and that would be 130 degrees. So then angle OAB is going to be equal to angle OBA, which is 180 minus 130 divided by 2, and that's going to be equal to 25. So then angle ABC is going to be equal to angle OBC minus angle OBA, and you plug in values that you figured out previously, and you would get 40 degrees. So notice how we use the correlation between knowing that angles and arc measures they're going to be related to each other. So then as a result, we can just plug in, we can set up equations, and then we can plug in numbers that we know, and then eventually get to the answer that we want to. Okay, I'll go ahead and go to the next problem, or next slide. So this is important information, but the measure of an inscribed angle is 1/2 the measure of the arc it intercepts. So if you look at the example, angle PQR is equal to arc PR divided by 2. So I'll leave this up here.
And what do you mean by it?
But I mean, what's your question?
I'm asking you, what does the angle PQR equals the arc PR over 2? What does it quite mean?
So the measure of PQR, that's going to be equal to the measure of arc PR divided by 2.
So it's so how many? So does that mean how many degrees of PQR is equal to the line that connects P and R, the curved line, the arc divide by 2?
Yeah, so this angle PQR, if you were to rearrange this equation, it would be 2 times angle PQR is going to equal arc PR. So, okay.
So can you say that again? Didn't quite catch it.
Okay. So if you were to rearrange this equation again, what you would do is, you multiply 2 on both sides, so then you would get 2 times angle PQR is equal to arc PR. That's another way you can think of it.
So angle PQR times 2 is equal to PR. In which way? Just times 2 equals the angle Q is equal. The angle PQR is equal to arc PR over 2. In which way? I'm just asking. In which way?
Wait, what do you mean which way?
I mean, is it like angle PQR the length or how many degrees?
It's the degrees. I would say it's
So you could measure the angle PQR by using its how many by the degrees. So if
Mhm.
it's 60 degrees and then you multiply it by two, it would be 120. So that would be PR's length, wouldn't it be?
Yeah, that would be the degree measure of arc PR.
Okay, thanks.
Yeah.
He said it equals the length of PR. What it means by arc PR, it means that if we have like this circle, the circle center is O, like POR, not the length of PR.
I think it would make sense if we went over the next problem example. But okay. So knowing that triangle ABC is inscribed in the circle, angle A is equal to 70 degrees and arc AC is equal to 130 degrees. And you want to find angle C.
An arc, but I don't quite get it. What does arc AC?
Well, arc AC means is, do you see A and C on the circle?
I know, but what does it mean by 130 degrees?
Like that's the,
Where is the angle? Don't slap your forehead.
And like, I think I can explain it. Like, you can annotate on it and maybe show him.
let's see. Well, okay, if you look at this image here on the right, you see that it says AC. This is arc AC, right? You see the 130 degrees right here. If you were, okay, so let's say that's like, okay, that's going to be, imagine if you were to draw an angle that where the vertex is in the center of the circle and then it touches point A and point C, that would be 130 degrees. So then that would,
So that's like if you transform the arc into a like an angle. Like
yeah, exactly.
Right.
Yeah.
You draw it straight and then it would be that. So
Yeah.
okay.
Yeah, that's what it is. Whereas for, sorry, we're going to go back. But for this one, this is not at the center of the circle. This is the vertex of the angle is touching the circumference of the circle. It's not at the center. So then this measure is going to be different from the arc's measure. That's why you divide by 2.
Okay. Got it.
Okay. Okay, we can go ahead and go over this problem. Okay, so since angle B is inscribed in arc A, angle B is going to be equal to arc AC divided by 2. So we would plug in arc AC, and then so it would be 130 divided by 2, and we would get 65 degrees. So then angle C would be equal to 180 minus angle A minus angle B, and you would plug in those numbers and you would eventually get 45 degrees. Another solution, another way you could have approached this problem is that since angle A is inscribed in arc BC is going to be equal to 2 times angle A. So this is what we previously did when we rearranged the problem. So we would have multiplied 2 on both sides and would have gotten the arc is equal to 2 times the inscribed angle. And in this case, it's going to be equal to 140 degrees. So arc AB would be equal to 360 minus arc AC minus arc BC, and you would plug numbers in, you would eventually get 90 degrees. Remember, when we're dealing with arcs, we're dealing with 360, the complete circle measurement. So that's why we would use 360, not 180. Since angle C is inscribed in arc B, angle C therefore would equal arc AB divided by 2, which is equal to 45 degrees. So those were 2 different methods that you could have used to solve the problem. I'll leave this up here for a few seconds and then we can go on to the next slide. Okay. Okay, wait, let me get out and fix the typo. There we go. Okay. So this is more important information. Any 2 angles that are inscribed in the same exact arc are equal to each other. So for example, angles B and C are inscribed in arc AD because you can see that 2 of their
Okay, so let me just get this straight. So because any 2 angles that are inscribed in the same exact arc are equal to each other.
Mhm.
Okay, so that means the angle B and angle C are inscribed on angle AG. Therefore, angle angle B equals angle C.
Mhm.
Can I have a can I also say that if you look closely, triangle ABP and CPD are symmetrical.
Yeah, they would be because you're dealing with the same angles.
And they all share one same point, P.
Mhm.
I would also say ABP is congruent to DPC.
So does that mean that if BP and CP are equal to each other and AB and DC are equal to each other, that means angle B and C are equal to
Yeah, I'm pretty sure.
Because the triangles would be congruent to each other, so then the measures would also be equal to each other. I'm trying to think though, if there's a case where, for example, if let's say that this was point D right here. Here, let's go with the pointer. Point D was right here. And you were to draw an inscribed angle that was in arc AD, so then it would be, I think that would end up, being an isosceles triangle, because it would be, let's say that it was drawn directly in between, in the middle of arc AD, that would be an isosceles triangle that would be different from triangles APB and DPC. So I think it depends. Like the angle measurement would be the same, I would say, but then it doesn't necessarily mean that the triangles would be the same. Because, I mean, if you were to look at it, a triangle, let's say that, okay, that's like point, I forget what I labeled it previously, but it's like point Y. That would be an isosceles triangle, triangle AYD, and the other two triangles that would be formed, they wouldn't be isosceles triangles. So you can, when it comes to like making assumptions that yes, the two triangles are equal to each other, I mean, you would have to go through a series of steps, but for now, just don't assume that, okay, the angles are going, just because one pair of angles are the same means that the entire, like those two, the two triangles are congruent to each other. You can't necessarily assume that unless you prove that, you know, the sides, unless you figure out like, oh, these triangles are congruent to each other by SAS or AAS or SSS. I mean, it depends on which congruence theorem you use, but so just be really careful when you're trying to say that, oh, these two triangles are congruent to each other, because we know that, yes, any two angles that are inscribed in the same exact arc are equal to each other, but then that doesn't necessarily mean that, okay, the triangles that are formed by, you know, like drawing two different chords are also that's going to form two triangles that are going to be congruent to each other. We can't conclude that unless we prove it by using SAS. So yeah, just be really careful when it comes to making those kinds of assumptions. Okay. Next we have problem 12.6. So chord AC and chord BD meet at P as shown. Given that AP is equal to PB, show that AB is parallel to CD.
Is that an equal sign or do you mean just parallel?
Oh, wait, what? The sign here?
Yes.
That's, yeah, if you see the sign, that's showing that AB is parallel to CD, or that, so that's, in this case, you want to show that AB is parallel to
So
CD.
only if angle A equals angle C and angle B equals angle D, will they have the condition that, well, that AB is parallel to CD?
That could be part of it. Hold on, I'm gonna sneeze. Jeez. Okay. Sorry. Okay. Okay, we can go over the problem together. So, okay, since AP is equal to PB, that's going to say that angle PBA is going to be equal to angle PAB, because we're dealing with an isosceles triangle here. So angles CAB and CDB are inscribed in the same arc. So that means that angle CDB is going to be equal to angle CAB. So angle CAB is the same angle as angle PAB. So that means that angle CDB is going to be equal to angle PAB, and angle PBA is going to be equal to angle DBA. And because angle CDB is equal to angle DBA, line segment AB is going to be parallel to line segment CD. So I'll leave this up here for a few more seconds and then we can move on to the next slide. Okay. So next we have section 12.2, angles inside and outside circles. Okay, next we have problem 12.7. So knowing that arc AB is equal to 40 degrees and arc DC is equal to 80 degrees, find angle AEB. Okay, we can go ahead and go over this problem. Okay, so we're going to apply what we learned about inscribed angles to this problem by drawing AD to create inscribed angles. So angle DAC down here is going to be equal to arc CD divided by 2, which is going to be equal to 40 degrees. And angle ADB right here is going to be equal to arc AB divided by 2, which is going to be equal to 20 degrees. So angle AED is going to be equal to 180 minus angle EAD minus angle EDA, which is 120 degrees, and angle AEB is going to be equal to 180 minus angle AED, which would be 60 degrees. Okay. So next we're going to go over more information about inscribed angles. So the measure of an angle created by the intersection of two chords is the average of the measures of the arcs intersected by the chords. So that was a lot of words, but hopefully this example will clear it up. So for example, angle PTS is going to be equal to angle QTR, and that's going to be equal to arc PS plus arc QR divided by 2. So that would be equal to x plus y divided by 2.
Because they're an intersection, aren't they all 90 degrees?
Yes, in this case they would be. Yeah.
Okay.
Well, I mean, you can't always assume. Like, for example, actually, I kind of take that back. Imagine if, let's say that line PR was, it was like, instead of it forming like, you know, a perpendicular intersection or an intersection that looks like it's perpendicular to SQ, if it was more of a slanted intersection, then those four angles, obviously they wouldn't be congruent to each other. But I mean, I think you've learned, and Adrian and Elsie said this previously, in geometry you can't always judge, like you can't say that, oh, these two lines look like they're perpendicular, so this must be perpendicular. You have to always look at the measurements and then eventually prove if they are perpendicular. Oh, these two lines are perpendicular to each other. So yeah, in geometry you can't always assume things, especially since there are a lot of times when they're not drawn to scale. In this case, though, it looks like they might be perpendicular, but at the same time, they might not be perpendicular. So yeah, just be careful about like making those kinds of assumptions.
Okay.
All right. Okay, so next we have problem 12.9. Oh, here, let me at ease. I forgot to animate this. Hold on. Okay, there we go. Okay, So given that arc DE is equal to 110 degrees and arc BC is equal to 20 degrees, find angle DAE. And the image below can give you a hint as to what you could do to figure out what angle DAE is.
Just like you said before, can we go back to some important points?
Yeah. Do you want this one? Or
Can you go back a little bit more? Now you can go back.
to the problem? Oops. No, yeah, we already did that one. Okay. Okay, we can go ahead and go over this problem. So first, what we want to do is, as shown, we would draw BE to create more inscribed angles. So angle BEC would be equal to 20 divided by 2, which is 10. And then angle DBE would be equal to 110 divided by 2, which is 55. Hence, angle ABE would be equal to 180 minus angle DBE, which would be 180 minus 55, and that would equal 125 degrees. At the same time, angle DAE would be equal to 180 minus angle ABE minus angle BEC. And that would be equal to 180 minus 125 minus 10, which would be 45 degrees. And that would be our final answer. So notice how by drawing inscribed angles, you can do a lot more with problems by building on the information that you've already been given. And then you can find even more angle measures. Okay, I'll go ahead and move to the next problem. So this is more information about inscribed angles. So two secants meeting at a point that is outside of a circle from an angle that is equal to, form an angle that is equal to 1/2 the difference of the arcs that they intercept. So just for review, two secants, or a secant line is a line that goes through a circle twice, or it intersects the circle twice. So for example, for line ZX, it intersects the circle at point Y and point X. Same thing for ZV, intersects circle at W and V. So then as a result, these two lines are secant lines. And just to go over, yes.
Question. Is the angle G equals B times A over 2 or B minus A over 2?
It's B minus A over 2.
Okay.
So it's going to be equal to, so you see 1/2, so that's going to be the divided 2 part. So it's 1/2 the difference of the arcs that they intercept. So if you look, that's going to be arc A and arc B, and you subtract B from A. And you would find the difference and then divide that by 2.
Doesn't arc B equal arc A?
No, they're going to be.
Oh yeah, yes.
Yeah.
Yeah, not.
Okay. So I'll make sure to go back to this slide while we're working on problems. So let's go to the next problem. So in problem 12.11, We want to find angles BPC and BEC given that arc AD is equal to 40 degrees, arc AB is equal to 120 degrees, and arc DC is equal to 100 degrees. And if you want to go back to the previous slide, just give a shout out. Hold on, I'm gonna sneeze again. Okay. Okay. So all the arcs together in one circle, they have to add up to 360 degrees. So in this case, arc BC would be, if we were to plug in the numbers, they would be 360 minus 120, so that's arc AB, minus 40, which is arc AD, minus 100, which is arc DC, and that's going to equal 100 degrees. So then we have angle BEC right there is equal to arc BC plus arc AD divided by 2, which is going to be 70 degrees, and angle BPC is going to be equal to arc BC minus arc AD divided by 2, which is 30 degrees. Okay, so we can go ahead to the next problem. I forgot to the animation thing. I'll leave the diagram in. Actually, let me take that out. Okay. So in problem 12.13, angle P intersects the circle at 4 different points. The arcs WX, WZ, XY, and YZ are in order from smallest to largest, and each of the last 3 arcs are 42 degrees larger than the arc listed right before it. Find angle P. Okay, we can go ahead and go over this problem. So first we want to label the diagram with the known information. So let the smallest arc equal x. So then the other 3 arcs are x plus 42, x plus 84, and x plus 126. We would find x, but we don't have to because angle P is equal to the difference of arc XY and arc WZ over 2. So if we were to plug in those numbers, we would get x plus 84 minus x plus 42. The x's would cancel out, and you would divide that by 2, and in the end you would get 21. Okay, I'll leave this up here for a few more seconds and then we can go ahead and take a break because it is 7:45. Okay. You can go ahead and take a break now and we will meet back in 5 minutes. Okay, so it is 7:50, so I would like to go ahead and get back into the lesson. Okay, so next we're going to cover a new section that deals with tangents. So tangents. Tangent is a line that is tangent to a circle. Oh, sorry. A line that is tangent to a circle is perpendicular to the radius that is drawn to the tangent point. So that means that, for example, if you look at line M, just for review, line M is tangent to circle O because it touches circle O at exactly 1 point. And as a result, it's going to form a perpendicular intersection, and that is going to happen at point B. Okay, so back to the explanation. Additionally, a line that is drawn through a point on a circle that is perpendicular to the radius drawn to that point must be a tangent line. So that's just saying backwards. So if there's a line that is drawn and it is perpendicular to the circle at 1 point, then it must mean that the line drawn is a tangent line. So for example, line BC is perpendicular to, it should say BO, sorry, the radius, because if and only if line BC is tangent to circle O. Oops.
What does tangent mean?
Tangent just means that the line on the circle the line touches the circle at exactly 1 point.
Mm-hmm.
Line
Well,
touches the circle.
It
So
it
angle,
touches at point B, which is the radius, right?
so that means if the line in BC is tangent to circle O, so what does that mean?
So that means that BC touches circle O at exactly 1 point. And that's going to be at that's going to be at point B.
Also, is if a typo? There's two F.
No, okay. This is an abbreviation for the term if and only if. We went over those when we were discussing proofs. But yeah, so what this statement is saying is line BC is perpendicular to BO if and only if line BC is tangent to circle O. So what that is saying is that line BC can be perpendicular to BO as long as BC is tangent to circle O. And it has to be tangent to circle O in order for it to be perpendicular. Otherwise, it wouldn't be. Okay, so I'll move on.
Get it.
Yes.
I still didn't get it.
Okay, so let's look at line M again. Okay, so do you see how line M is touching circle O at 1 point?
Yeah.
Yeah, okay, so that means that it's a tangent line. So a tangent line, as long as it touches a circle at 1 point, it just has to, and at only 1 point, then it's tangent. If it's touching the circle at, let's say that there's a line that goes through the circle at 2 different points, that's not going to be tangent to the circle. That's going to be a line that's it's going to be, huh?
I got it.
You got it?
Yeah.
Okay. Okay, so we have more information about tangents. So an angle that is formed by a tangent and a chord, where the tangent point is an endpoint, equals 1/4 the arc that is intersected by the angle. So for example, Okay, let's actually go over some terms. So tangent, we just went over that. A chord is a line segment that touches two parts of the circle's circumference. Okay, so let's look at the example. So in this example, line M is tangent to the circle at point A. So that means that angle ZAB is going to be equal to 1/2 of arc AB. It should say, sorry, it should not say 1/4. It should say 1/2. Oops. There we go. Okay. We of course can go back and look over this information because this is like, I mean, we're just building on information over information, but it's, I mean, it's eventually going to be a lot of information piled up, so we can always go back to these slides. Okay, so here's more information about inscribed angles. So an angle between a tangent and a chord is often called an inscribed angle. The same name used to identify an angle between two chords that share an endpoint. So if we go back, so angle ZAB, that would be an inscribed angle, but then at the same time, we can say that's angle XPY, that's an inscribed angle, or angle BAC, that's going to be an inscribed angle. Actually, sorry, angle XPY, that would be, I would say that would be an angle that's like extended outwards. So I'm pretty sure that you wouldn't call that an inscribed angle. I would say so. I would say that angle BAC and angle BDC, those would be inscribed angles because because their vertex is touching the circle circumference, whereas angle BPC is extending outside of the circle and its vertex is outside of the circle. So back to where we were. Okay. Okay, so we just went over this information, and the measures of both types of angles equal 1/2 the measures of the arcs that they cut off. So that's something that we've been dealing with throughout the lesson. I'll just stay on the slide for a few seconds and then we can go on to the next slide. Okay. So we can draw two tangent segments to a circle from a point that is outside of the circle. So in this case, the two tangent segments would be PA and PB, and they're extending from a point that is outside the circle, which would be point P. These tangents that are formed are always equal to each other in length. So PA would be equal to PB. So, however, the one condition is that the two tangent segments have to extend from the same point that is outside of the circle. So it can't be like, oh, there's, let's say that there was point O where the pointer is. You can't, and then let's say that there would be segment OA and then segment OB. You can't say that, oh, segment OA is equal to segment PA, or segment OB is equal to segment PB. They have to subtend from the same point.
I have a question.
Yes.
So if you connect A and B, wouldn't
Mhm.
that technically mean that PAB is a isosceles triangle, so that's why they are equal to each other?
Yes, or you can think of it as, yeah, you can think of it as, you can think of it like that in one way. But yes, good thinking. Okay. So next we have problem 12.18. In a circle with a radius of 10 centimeters and the center O, point P is 25 centimeters from the center. Point Q is on the circle so that PQ is tangent to the circle. It should say 2. Find PQ. And there's an image that goes along with it. So I will get rid of the animation. Whoops. Stop. Okay. Sorry about that.
Can you go back to the slide with the Z point? Yeah,
Okay.
I need to look at this. Second.
Remember that is formed by tangent and correlate.
Okay.
I still need to read.
Okay.
Okay, done.
Okay. Do you need this slide or are you good?
We could leave it on.
Okay. Okay. I'm going to go back to the problem. And then I think this one is pretty straightforward with the image. Okay.
So do we just use the 25 squared minus 100, and then we
The Pythagorean Theorem, yes.
yeah
Mm-hmm.
okay, but we could just use that one.
Yeah.
Let's use that kind. So this is kind of silly sometimes.
Yeah, so what you would do is use the Pythagorean Theorem. So then, as Max was saying, there should be a parentheses, closing parentheses there. You would say OP squared is equal to OQ squared plus PQ squared, and then you would rearrange the equation so that you would get PQ is equal to the square root of OP squared minus OQ squared, and that would equal square root 25 squared minus 100 and minus 10 squared. The 0 should be closing parentheses. So then this is just algebra part. This is the algebraic part of solving the problem. But in the end, you would get 5 times the square root of 21 centimeters.
Okay.
Okay. So let's go to the next problem. So our next section, which deals with problems. Okay. And some more new information. So side quadrilateral is a quadrilateral that can have a circle be drawn around it, and the circle must pass through all 4 of its vertices. This quadrilateral is said to be inscribed in the circle. The opposite angles of any cyclic quadrilateral add up to 180 degrees. Okay.
I'm
Some
still-
problem? Yes. Oh, you want to go back? Okay.
When do we play a Kahoot?
We're gonna play Kahoot soon.
Just don't think about it right now.
Okay. So, okay. Okay.
Okay. I'll go ahead and move on. We can always go back to the slide too. So in the figure, PC is tangent to the circle, and PD is a bisector of angle CPE. Find the measure of the arc from A to E that does not go through point C. So we're going to be focusing on this arc, given the measurements of the arcs and angles shown in the figure. Should say angles. Okay, we can go over this problem together. Okay, so since angle DQE,
Can I ask you a question?
yes.
What does bisector mean?
So bisector is when, let's see, okay, PD is the bisector of angle CPE. So that means that the segment PD that splits angle CPE in half, so that the two new angles that are formed, so that would be CPD and DPE, those would be equal to each other. Okay. So since angle DQE, right there, is the average of arc DE and arc CB, that means that arc CB is going to be equal to 30 degrees. We have arc CB, so then we can find angle CPD. And angle CPD is going to be equal to arc CD minus arc CB divided by 2. So that's going to be 70 minus 30 divided by 2, and we would get 20 degrees. So DP bisects angle CPE. So we know that angle DPE.
So bisector is kind of bisector. Can you see that? Can you see what bisector means again?
Yes. So bisector can be like a line segment, or it could be a line too. But it's, in this case, we can say it's a line segment. But it's a segment that splits one angle, so it intersects an angle, and then the two new angles that are formed are going to be equal to each other.
So like the
So-
angle P gets, so bisector is the line segment PD.
So then it splits it into CPD and then DPE, and those two angles are going to be congruent to each other.
So basically, what a bisector does is cut things into equal parts. And you can run multiple bisectors in about anything. ray bisectors and ray bisectors and line bisectors.
Yeah. Okay, so back to the explanation. DP bisects angle CPE, so then we know that angle DPE is going to be equal to angle CPD, and that's going to be equal to 20 degrees. Since angle DPE is equal to arc DE minus arc AB divided by 2, that's one of the things that we just previously learned, we figured out that arc AB would be equal to 10 degrees. So now we can find our desired arc since we know the measurements of the other arcs of the circle. So that would be 360 minus 50 minus 70 minus 30 minus 10, and that's going to be equal to 200 degrees. Okay, I'll go ahead and go to the next problem, and this will be our last problem, and then we can go and play the Kahoot. So 3 congruent circles with radius 1 are drawn inside triangle ABC, an equilateral circle. The circles are drawn so that each circle is tangent to the other 2 and to 2 sides of this triangle. Determine the length of one side of triangle ABC. And
Can we see what it actually looks like?
yeah, here we go. Okay.
That's pretty complicated. That's really complicated.
So just there are different parts of it that are dissected so that they're going to go with the explanation, but you can see that there are 3 different circles, and they're tangent to each other, and they're tangent to the 2 sides of the triangle.
Can I say something?
Yes.
Any problem is easy. All you need to do is just know where to start and where to end.
Yeah.
So just try to think about where do you want to start in this? Where do you want to start and what do you want to end with, aka the solution?
Yeah. Okay, I'll go ahead and go over the problem. So what we want to do is want to create simple figures to work with. So we start by connecting the centers of circles and drawing radii to points of tangency. So let's look at rectangle WXYZ. This is going to be a rectangle because XW would be equal to YZ, XW is parallel to YZ, and angle XYZ is equal to 90 degrees. So then WZ is going to be equal to XY, which is going to be equal to 2. Therefore, we only need to find CW to finish because we know that BZ is equal to CW. So what we're going to do next is we're going to draw CS. Wait, no. It should be, hold on. I'm trying to figure out where I made a mistake. It's either sorry, okay, yeah, it should be CX, not CS. Okay, so here, let me change that. Okay, there we go. So what we do is we would draw CX to build the right triangle, and we we see that CX bisects angle ACB, since circle X right here is tangent to AC and BC, and its center is equidistant from them. So because, oh, Siri got activated, sorry. Okay, since circle X is tangent to AC and BC, and then its center is equidistant from, okay, sorry. Because angle XCW is equal to angle ACB divided by 2, which is going to be equal to 30 degrees, triangle CXW is a 30, 60, 90 degree triangle. Therefore, CW would be equal to XW times the square root of 3 minus the square root of 3. And in conclusion, BC would be equal to BZ plus ZW plus WC, which would be 2 plus 2 times square root of 3. Okay, so leave this up here for a few seconds and then we can go ahead and start playing Kahoot. Okay.
There's a typo.
Yes.
In the first line, in the first and second line, it says on equilateral circle.
Whoops. Or drawn inside triangle. Why did it? Okay, there we go. Okay, now I can go ahead and play Kahoot. Let's see. Transformation. We can go ahead and play this one.
Oh yeah, that music is tasty. Yeah, that music is tasty. And Marcus Person, the founder of Minecraft, of course. But now no tasting music. Oh yeah. Alright, no tasty music. Okay.
Why do you call it tasty? You can't even eat it.
Just kidding. That's just an expression. It doesn't taste. Can you turn the music up a little? And then that will be
If I
tasty.
turn it up, I can't hear you guys.
But I want to say something. Can you turn the music louder? We can't really hear it.
No, but what I'm saying is that if I turn up the music, then I can't hear you.
Just halfway through. Just halfway through. Just halfway
A
through.
little bit forceful.
Just do the halfway through. That would do it.
We're only gonna have 3 players today. Okay. We can go ahead and start then.
Okay, so what's the perimeter of the figure shown? Let's see. Don't know.
My brain hurts just watching this.
Kinda got it. Yeah, I got it right. Yeah. Yeah, silly. Do it over. Marcus person. Only Marcus person. A domino is two. A domino is 20 area. Is it 60 units? So 40, 20, 10, 10. So it's I got it. So it's I got it.
Nice.
One more mark.
Let's go.
Yes, I did it. Yeah. Is the answer 200? Is it?
PM stands for perimeter.
Okay. Okay. Let's see.
So
Two blocks.
at point. Where is point D?
In opposite. They met at point D.
So
Where
you have to
is
figure out-
Where's D? Where's
It doesn't
D?
have to tell you where's D. You have to draw. You have to find it yourself.
Yeah, but we don't know where D is.
you have
Well,
to
it
figure out
it gives you, but the question tells you like things that you can use to find where D is.
Okay, so
It doesn't show you. If it showed you, it would be too easy.
okay. Didn't quite get that right. So yeah. Marcus person. Meeting.
Oh yeah. And
Backyard. He could walk. Or find the area. I don't know how to calculate that.
It is possible to calculate.
Aha! I got it. Aha. Where am I then? Yeah. Never got it. I got it wrong because I don't really know what it looks like. But don't blame me for that. Okay, yeah. Shade it. I think I got it right because I guess that was 6. There he is. So inches. Let's see. The shaded area is so don't quite get it. So let's see. Looks like we're going some serious calculation, don't we? Need serious. Some serious calculations. see this calculation. So it might be okay. So
Okay. Here, I'll
Uh,
explain this one.
Powers 2 to the power of n.
Okay, so what you could have done is you could have split this up. So you would have gotten two rectangles. So you could draw a line here. So then you get 2 times 4, which is equal to 8. And since you know that this is 2 inches, this also has to be 2 inches. So then it would be 10 times 8. So you would add up the areas of the two rectangles. So you get 80 plus 8, and then you would get 88. And you know that the shaded region's area is 78 square inches. And this includes the area of the non-shaded area, or non-shaded region's area too. So what you would have done is subtract 88 minus 78 to get 10. So you know that the area of the non-shaded region is equal to 10. And you know that one side is equal to 2. So that means that the length of this non-shaded region has to be 5. So then you would have gotten 2 plus 2, which is 4, 5 plus 5, which is 10, and if you add that up, you get 14.
But that's 2 to the nth power inches.
Oh no, no, this is a sign for inches.
I thought that was 10 to the nth power.
No, it wouldn't be that complicated.
I have an answer steak.
No, Alvin, it's really probably natural because it's in the same place as an exponent.
Yeah.
So you would obviously be confused.
I don't quite get it sometimes. It just gets too weird.
It's so easy.
Oh yeah, but hard for me.
After this problem, can you explain this one? Because I really don't get it.
Okay.
Yeah, but
I can explain too.
So
okay,
one way that you could have thought of it was the way that I would solve this problem is splitting it up into the the square that we're the smaller shaded in square that we're already given. So for example, you can split this big square up into 4 different rows. So this would be row 1, row 2, and then you can draw a line here and get row 3, row 4. So then, for example, this one, if you were to draw a line here, this would be two the smaller squares cut into 2. So then if you would combine those 2 halves of the square, you get 1 square. So that would be, okay, you have 1 square in this row. For this row, you can see, okay, you have 1 full square, and then you can say that there's another full square here,
okay, so
drawing a line,
so
and then you combine
you
the
could
2
just
halves,
calculate
and you
it.
get 3 squares. And then for this second row, you do the same thing what you did in this row. You would have 2 full squares, and then you'd have 2 halves of 1 square. So then that would be 3 squares again. And then finally, in the last row, you would do what you did over here, and you would combine 2 halves of 1 square, and you get 1 square. So that would be 1, 2, 3, 4, 5, 6, 7, and then 8. So then the ratio compared to the 1 small square to the big giant square is going to be 1/8, because it takes up, you need 8 of the smaller squares to create that 1 big square. Okay.
I didn't have enough time to solve it.
Okay. So for this one, you would have figured out, okay, so these are two squares and this is a triangle. So you figure out the areas of the two squares and then the one triangle, and you would add them up and set them equal to 850. And then you would have done simple algebra from that point, and then you would figure out x.
But when I solved the area, when I added the areas together, I got 34x squared. But 850 isn't divisible by 34, I believe.
I got 34x too.
It's 34x squared, you mean?
4x squared is
Yeah, I mean 34x squared. Yeah, I got 34x squared, and the answer would have been really different. It would have been 25.
Yeah, totally.
25 total.
Maybe we should do this problem.
So you would have gotten 34x squared is equal to 850, right? So that would
Yeah.
have been 850 divided by 34. You would have gotten 25, right? So 25 is equal to x squared. And then you would square root both sides, and eventually you would get x is equal to 5.
Wait, is 860 divisible by 34?
It's 850.
Oh, is 850 divisible by 34? Oh, it is. Okay, I didn't see that.
Yeah, I just said it would have been 25.
Yeah.
Well, I'm still first at least. What, shadows? Wait, no picture? Come on.
Wouldn't figure out what it
Imagine in your brain.
can't figure it out how the jack house.
Oh, I get how. I get it.
There might not be enough time. I don't know.
So
Wait, I don't have enough time. Wait, I don't have enough time. Come on.
It's in an 8:7 ratio.
Yeah, but I don't have enough time.
Like there's a ratio.
Yeah, it's ratio, but I don't have enough time, okay?
It's an
Yeah,
8:7 ratio.
Even if we know
I
the
know it
ratio,
is. Oh, wait. No number.
still I can't figure it out. So maybe I'll just let the time go by. All right.
Please, POS, 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 please.
Stop.
Oh, you can skip the question now.
I got it right.
Yeah, I got it right.
I got it right as well.
No, one of us got it wrong.
Two triangles are parallel. Yay, there's finally a picture. The answer is not a red. The answer is not a red.
Oh, I got it. Yeah, I get it. Yeah, I got
Do
it.
not choose red. Do not choose red.
Really, are you crazy?
Do not choose red. I'm serious.
Okay. But at the same time, I think you're lying.
Sure, then choose red. You'll get it wrong. I promise. If you choose red, you'll get it wrong. I promise. Who chose red? I told you. Oh, you chose red. Told ya. Whoever chose, yeah, Kessler, I told you to choose red. Not to choose red, I mean.
I think I got it. Yeah.
Yeah.
Yeah. Podium. Let's see. So that's Gatling P2000. That's E. And then it's Mark. That's definitely Marcus Person. Yes, I got it right. Yeah. That really was Marcus Person, but that wasn't me who typed it.
Okay, so it is me in class. Well, thank you guys for coming, and I'll see you guys next class. Bye.
Bye. Thanks for teaching. Thanks for
Bye.
answering my questions.
Bye. Thank you for teaching.
Answering all my questions.